Hi and welcome. There's a lot of people on the call that don't know who I am. I'm Eve McDonald, EMESRT Coordinator. Today's webinar is focused on the EMESRT Industry Initiative Mobile Equipment Fire Management. Our webinar presenters today are Tony Egan, EMESRT Advisory Group Member representing Glencore, and Mark Gearson, EMESRT Advisory Group Member representing Rio Tinto. So agenda item 1 will be covered by Tony, and agenda items 2, 3, 4 and 5 will be covered by Mark. I'll now hand over to Tony. Tony, if you wouldn't mind, please.
Yeah, good morning, everyone. Thank you, Eve. I too am having trouble with connecting. I'm on a major network and there's issues in Brisbane here, I think. So I'm also working off my phone. So I'm just going to quickly give you a background of EMESRT for those people that haven't been involved with EMESRT before or understood how we operate. I think there's often confusion between us and, say, standards groups and other industry groups around the world, and we certainly operate quite differently. So I'll take you through that. So we're a mining industry body formed in 2006, and originally we started to influence OEM designs, and we tried to take a different approach in how we did that. And I'll explain later how we've morphed a bit in that respect, but that was the original intention, was to influence designs from the factory. The way that we've done that is using a common industry voice and trying to reduce the health and safety risks for both operating and maintaining equipment. We try to deliver practical outcomes, and the idea of EMESRT is it's not about just the EMESRT members that do everything. It's actually about coordinating a community of users, researchers, designers, OEMs, etc., that can come together to solve the issues that we face. The other thing, I suppose, is that we try to challenge the industry about where we're currently at with things and move on to improving those things and where possible, removing the problems from the designs. So next slide, please, Ed. So fundamentally, EMESRT was formed because of what we termed the design gap, the difference between what the OEMs were offering from the factory and what users had identified as exposures in their own workplace. And that design gap really can only ever be filled can be shrunk by the OEMs because they're in control of that fundamental design. There's a whole industry out there of third-party providers who've built businesses about filling that design gap. Ultimately, for us as users, shrinking it is the way to go, but the reality is that there'll always be some level of third-party involvement. And this topic we're on today is one of those. The other key principle that we changed in 2006 was about marketing, controlling research and development spend. And typically, as engineers, we've always talked to the technical people that we've dealt with, and they've probably understood what we've told them. And then they've gone back to the factory and said, well, we think we need to, these issues are here, we need to change them. But having worked for 2 OEMs myself, the marketing guys control where the funding is spent in terms of R&D. And so often, although they probably understood and agreed with what we were telling them, they didn't have a business case. So the only way to really address that from the user side is that having that common industry voice, defining a problem, not solution. I think that held us back a lot 20 years ago, where individual businesses were faced with a piece of equipment that didn't meet their needs. They came up with an idea and then they told the designer, that's what you've got to do to fix it, the solution. Whereas what we've tried to do in EMESRT is clearly define what the problem is. And my experience with designers is when they really understand what your problems are, they'll go away and come up with something far better. Otherwise, you're just band-aiding what you're currently, the current situation. In terms of key principles and how we operate, so the designing beyond standards is the key. I remember when we first met with all the OEMs 15, 16 years ago, they said they go to the standards as the minimum. And the real challenge was getting them to design beyond standards, and that's where this whole approach comes in. It's also about balancing engineering and behaviour, the human factors aspects. It's something that we've not been trained in as engineers, and we're not very, in the past, not been good at it. And when you think about it, the designers are great designers, but they're not good users, and we're good users, but we're not great designers. So the reality is, if we don't come together, we're never actually truly going to solve the issues. and give both sides an understanding of the constraints that we face. The other part that we've tried to focus on is task-based design reviews. So being quite practical in the way that people address issues. In terms of the other parts is that you've got to respect that the OEMs have a business to run, and that we've got to appreciate that they are there to do their job, but it can be done better, as I say, when the end users are involved in an organised way. And the other part that's really been key over the last 16 years is open two-way engagement. Typically, as an industry, we've talked at the OEMs. This is what you need to do. You need to fix this, etc., rather than talking with them and working in a collaborative way to solve these issues. In terms of what EMESRT will and won't do, it's pretty important. And this is something we formulated way back in 2006, and it hasn't changed. So we're going to focus on design of earth-moving equipment in surface and underground mines. It's pretty important that a lot of industry bodies spread their wings all over the place. And there's a great saying about if you try to be everything to everybody, you'll be nothing to nobody. So EMESRT has been very disciplined in its approach, and particularly our focus has been around fatal exposures. So along the lines of that, we try to provide aligned design expectations, in other words, problems. We involve anybody that's interested. So even though there's a group of EMESRT members, and to be a member, you need to be a mining company because we're the ones with the problem, and we need to define those things. But it doesn't bar other people getting involved and being part of helping us move forward. We're going to share openly with all the people that are interested, OEMs and others, but without crossing any boundaries. I'll talk to that in a minute. We're going to provide information on leading practice to the OEMs and third parties. And today's webinar is a great example of that in reality. And we're also going to share leading practice to assist other mining users. And I said earlier about our original focus when we started was about the OEM designs. It became pretty evident quite quickly that if the users don't understand the risks in the same way that the problems in the same way that the designers do, then we've got a gap in the fact that they won't actually buy what the designers come up with. So a big part of changing the way this works is actually educating both the users and the designers in terms of understanding the problems. And that's been quite a challenging exercise. And I think this topic's been a really good one in the way that we've formulated an approach over the last 15 years to be able to bridge that gap. In terms of what we won't do, and this is really important, we're going to discuss any commercial issues or anything of an antitrust nature. We won't provide approval for OEM or third-party designs. We are not a standard or a certification body. We're not going to share confidential information with other parties. I mean, EMESRT has been built on trust, and that trust is sacrosanct. And if we lose that trust, EMESRT is finished. So we guard it very carefully, and we guard the information that we have in our engagements with the different groups very carefully. And the other last thing is we won't impose adoption of the solutions on any of our member companies. We're not here to tell people what to do. We're here to educate people. And through that education, they should change. You would think they would change the decisions that they're making. So it's not about forcing issues. It's about sustainably changing them. So just finally, we were asked a while ago, what do we think the success factors of EMESRT have been? And these 5 things came out, which is working in an industry level focus, having a real world business understanding of the financial drivers and leverages. That's not just on the mining side, but also on the third party and the OEM side. Because if we can understand how their businesses function, then we can better influence them. Understanding that innovation is market driven, not pushed by technology. Many years ago, I sat in a presentation that had surveyed over 100 technological issues or items. And of that, there was only about a 5% success rate, where the people came up with a piece of technology and said, here, you need this thing. And the users all really didn't understand. But where it's been driven by users defining their problems clearly and understanding where the technology fits in, the success rate is far higher. And that's really been the approach from EMESRT. Good governance to cover our structure, funding and risk management and renewals and continuity. We have an advisory group, which is one member from each of the company representatives. And that works well. And over the years, we've had people come and go out of that group, and we've been quite steady in the way that we've approached the way that we run EMESRT. And the last piece is really that we need senior management and decision maker endorsement. So one of the jobs of each of the advisory group members is to go back into their organisations and gain that support at senior levels, so that the EMESRT is aligned in what we're doing to the requirements of the companies. One of the things we do every year as part of the advisory group is the planning process. So we get together, and I mentioned a minute ago about getting input from senior management. At that planning process, we really look at the current topics we've got on foot and where we need to be taking them, and what's coming up. And as I said earlier, we don't try to spread ourselves too far. We'd rather be an inch wide and a mile deep on a topic than miles wide and inches deep. And we've certainly seen in the industry other groups that have really not succeeded when they've tried to do it that way. So we've learned from that. So really, there is a structured approach to how we plan and develop things and fund them. And this topic's been certainly one of those that's been through that process. So talked before about defining problems. The way that we've done that is through a thing called the design philosophies. Why are they called design philosophies? Because a lot of people tried to name them similar to things that already existed. And one of the things we've found over the years is that if you really want to get people to think about something, give it a name that doesn't exist, and they'll ask the question about what's a design philosophy. And then you'll give them a definition and it'll stick. So basically, they're problem statements, and they're there to highlight to the designer in key problem areas around machines, where as users we have issues. And really, what they're designed to prompt is three questions: are any of the problems that are noted in the design philosophies involved in the design that I'm working on or using? So if I was a user, I could do this the same. If they are, how material is that exposure that design issue creates? Is it fatal, or is it minor injury? And based on that materiality, how should that be addressed in terms of the design? If it's a fatal risk, obviously it should have a higher priority about how it's addressed than something lower. And I said earlier about understanding that people have businesses to run and there's priorities, and you can't do everything. One of the things that EMESRT has tried to do is give some level of priority to how things need to be addressed in terms of solving the problem. So, and the design philosophies underpin a lot. And you'll see DP4 there, which is the fire one. When these were built, they were quite succinct documents trying to highlight the issues. But what we've found as we've gone deeper into some of these topics, particularly vehicle interaction now, and which is under machine operation and control, and the fire topic and also the tyre topic, is that we've needed to go to a more detailed document to give people an understanding of how the problems have evolved and to give clarity to the designers around the issues that relate to those problems. So we've developed a document called a performance requirement that sits underneath the DP and complements the DP. And Mark's going to talk to us a bit about that today.
Thanks very much, Tony. Good morning or good evening or whatever time it is, wherever you're joining us from today. Look, I'm going to talk a little bit about the work that EMESRT has been doing around understanding mobile equipment fires and importantly what that means for all of us that operate that equipment. So in my piece today, I'm going to talk through 5 key things. The background and the EMESRT approach, including who was involved. I'm going to talk a little bit about the control framework, which is really exciting. That's something that we've been developing over a number of years through a number of our other projects. And it allows us to see this problem through a completely different lens. So I'm really excited about that. The importance of current state assessments. As about 80% of our fire events are typically of our own making, and I'll talk a little bit more about what I mean to that shortly. I'm going to talk about the status of the work, which has involved many of the individuals from the organisations that those on the call are on. are part of. And then next steps, including what tools and reference materials are available to the industry that can be accessed now. So, currently EMESRT is supporting 4 active industry projects, and we establish technical working groups in each project delivering on agreed project objectives. So each project's led by an EMESRT advisory group member, which Tony's already sort of mentioned, and they provide the strategic project oversight and coordinate all of the technical subgroups or technical content wherever that might be required. So this presentation is really on mobile equipment fire management, and why the focus on fire? Well, in our business in 2018, one of our underground operations lost a tool carrier, which involved an emergency evacuation over 500 staff, and it really tested our emergency processes and procedures. Now, that machine only had about 1,200 hours on it from brand new. And because of the robustness of the emergency response, fortunately, nobody was hurt. And thankfully, however, it did bring all sorts of attention, and for all the wrong reasons. The asset was totally destroyed, and normal operations didn't recommence until we were all comfortable we understood what we had to do going forward. So in our instance, we had equipment design issues, fire suppression installation issues, fire system integration issues, which triggered a discussion with the EMESRT advisory group to understand if others within the industry were experiencing the same problems. As a result, we initiated a project to understand what was happening across the industry and the regions we work across, and to see if there was any appetite to participate in an industry mobile equipment fire working group. That work identified that fire-related incidents were still quite compelling, and recognised the mining industry really needed a step change to improve its performance. And our project was born from that. And I think, early on we had involvement from our regulators. Next slide, please, Eve. And that process helped us verify and validate a whole range of what our thinkings were and whether our experience was isolated to any one particular member company. It was actually an industry problem. And I think in Australia, I think there's a fire event every day somewhere. So that sort of says that, hey, there's something we've got to do here. Part of any project we take up, we do a document review, and you heard Tony talk a little bit about the design philosophies, which heralded back to our kick-off days in 2006. So the relevant design philosophy for this topic is DP4, and the objective of DP4 is to prevent harm related to equipment fires to as low as reasonably practical, and including consideration in design for foreseeable human error. And we'll talk a little bit about that when we talk to the control framework, because I think whilst this subject has potentially been done to death by a number of other parties and other people, we have been able to, I think, unpack or view this through a different lens and potentially have something that we can really start talking with the OEMs about, and have already commenced that journey. And again, I'll talk a little bit about that in a minute. So DP4 talks around the design outcomes. you know, and that's about eliminating sources of ignition and fuel and protecting the operator should there be a fire event, and so on. And our project's an extension of the original work done in DP4. So as every EMESRT project kicks off, what we've found really, really useful is the development of an array diagram. And what you can see there is a whole range of vertical and horizontal fields that sort of start off as a blue box and then move through orange to green. And this particular array diagram provides the EMESRT community with a visual of what's already out in the industry, identifies who's doing what so that there's no crossover and rework, and where the gaps might be. And that helps inform how we as an advisory group approach the industry engagement strategy, the stakeholders, the analysis, who's in it for what, and helps us bring all the moving parts together so that we really can focus in on where we need to influence and where EMESRT, delivers the outcomes that Tony has already summarised earlier on in our presentation. So once the project's been approved, we use this diagram to update the advisory group, the technical working group, and the industry on progress. So you heard me talk earlier about who was involved in our project, and whilst this project's been going for a little while, you can see it's over 58 members now, representing 30 organisations, and they are spread across fire service providers, their end users, OEMs, regulators, academics, fire system designers. And all of these pieces come together and help us sort of form a picture. So the working group was formed, and our mandate was to identify design inadequacies and industry leading practice, review current research and identify the gaps, consult across the industry and share some knowledge, and develop and promote documentation to support our control framework self-assessments, and ultimately reduce our risks and the number of fire events. So if we use the universally understood heat, fuel and oxygen fire triangle, the group discussed and documented fire event areas of influence across the control framework, and I'll introduce that shortly. This slide sort of talks a little bit about the control framework, and those of you who are engineers will quickly pick up that it's aligned with failure modes and effects type analysis, human factors, and the definition elements, the ICMM critical control methodology. It allows us to apply a whole range of realistic inputs and experience to be mapped to the safe and productive operating states required to deliver business purposes. So if I look at it from a high level perspective, we sort of say, well, what are our required operating states? How do we lose them? You know, and that becomes our credible failure modes. And then how do we specify, how do we implement, how do we monitor, and how do we control to keep the required operating state in a healthy realm? And you know, what you'll hear me talk a little bit about as I go on is business inputs. And these are the specific things that you do on your sites to prevent a fire event. There's a whole swag of them. They might be pre-start inspections, they might be maintenance schedules, they might be fire service provider regular audits. They might be. There's a whole range of those sorts of things. They're examples of business inputs that we've put in place to maintain and sustain the health of the assets that we're trying to maintain. So if we use the control framework, it actually helps us develop a really deep understanding of complicated problems. And I'll show you a breakdown tree shortly. So if we use the control framework, it establishes both a whole of system overview and a structure that's linked to detailed operational practice. And if we work this way, provides information and insights about the dynamic interconnects between personnel, equipment, the work environment, the work groups carrying out the different tasks, and the overall coordination. So it helps promote the systemic identification of improvement opportunities. And this is where the control framework was really helpful in our project, because it actually helped demonstrate that we all have a role to play. You know, the mobile equipment designers, the fire system designers, the fire system maintainers, the mobile equipment electrical and mechanical and, you know, maintaining teams. Everyone's got a role to play. And what this control framework has allowed us to do is actually box all that up and table it so that it can be understood. So that's really helped us with this approach. So the mapping process requires a systemic review and assessment of the robustness and the reliability of those business inputs that I talked about earlier. All of those things that we do every day across our business that hopefully helps us get the end result, which is mobile equipment remains operating and doesn't burn. So if we follow these steps, it confirms the safe and productive outcomes relevant at the enterprise level. So, you know, what are the required operating states and the basis of the control framework and how it's been organised. Identify and catalogue the credible failure modes that can compromise each of those required operating states. And the way in which we've been able to build it, you can actually really drill down and focus on particular areas where you feel there might be an exposure, depending on how you operate this equipment and what your areas of concern might be. So based on each of those credible failure modes, we identify the business inputs that prevent or mitigate the required operating states being compromised, and that helps us then prepare a site mobile equipment fire control baseline by company, and that helps us then with our incident experience and our knowledge work out how we're going to implement and monitor. And I guess the control framework actually also, as we were applying it to some of our other industry problems, actually was really useful, because what we found was a lot of our critical risk, our semi-qualitative risk analysis, actions and all that sort of stuff, they were all reliant on human, or a good part of them, reliant on human behaviour, right? And there was no monitor and control element, right? So I'll give you an example. We following speed limits, turning up for work, fit, not fatigued. They're examples of where we have actions in our critical controls that are entirely behavioural related. And unless we can put in place the control and monitor elements to keep them from drifting away from our intent, we're going to have problems. So it starts opening the door to, well, how can technology help us make more informed decisions and support maintain the robustness of our controls. So it was really quite insightful. Like I said earlier, really exciting. So we then had a validation workshop. We talked through the control frameworks, and with a whole heap of industry knowledge, as I summarised earlier, and that allows us then to validate, check thinking, and to actually allow everyone to see everyone else's thinking, and that allows us to really quickly try and capture the key things that need to be managed. So as we develop the control framework, it requires, like I said, a systemic review, an assessment of the robustness and reliability of the various controls we have, or business inputs we call them. And the enclosed is the control framework applied to the actual fire event that I described, which sort of got our organisation pretty interested. So you can see there's quite a number of elements to it. So we had 6 required operating states, 6 credible failure modes, and 7 business input groups, and a whole heap of industry data to support that. We were starting to unpack this thing in a way in which it gave us just a little bit more clarity than perhaps what we'd had in the past. So the control framework current state assessments are a really critical component in the process, and knowing where you fit in relation to the industry good practice or leading practice is really important. So I guess the process requires us to prepare a work as documented baseline, and then update that work as documented to work as done. And this is where, you know, we test this stuff in the field by capturing that operational practice. And, you know, this is really useful, but also very confronting, because often, you know, we dream up, or the organisation dreams up actions that are intended to prevent a particular circumstance. And when we go out in the field and we start asking questions, people say, oh, no, we don't do it that way. Oh, no, that doesn't work. Or this doesn't happen, or that doesn't happen. So it's really quite confronting, and we've got to be really open to the feedback we receive. And that's another key element that's required pretty well across all of our projects, really, is the importance of creating the correct leadership engagement and culture to maximise the benefit from these exercises. So once we update the site equipment fire management baseline with the user requirements, that then helps us supply the detailed information about the design and the deployment of existing approaches. And that's how we developed PR4, which we'll now talk to, which is the performance requirement 4. So performance requirement 4 was developed by our EMESRT technical working group with all of the, you know, the key inputs, as I talked about earlier. And that was sort of pulled together in the third quarter of 21, I think, with several one-on-one webinars also being held with our OEMs. And we did that so we wanted to test our thinking, and we also wanted to give them an opportunity to discuss the document in detail and provide feedback or discuss opportunities for improvement, rather than just receiving something or that had been published. We were partnering with them right along the way, so we really wanted to continue to engage them, and that has pretty well been at the cornerstone of why I think EMESRT has been so successful over the last 15 or so years. We're just, I guess, facilitating the communication between the end users and the factories to get the best result. So the final draft of PR4 was tabled at the EMESRT Advisory Group November monthly meeting in 21, and it was then published. A few comments about that. You should probably read PR4 in concert with the Design Philosophy 4, because PR4 provides a whole range of comprehensive information for mobile equipment designers and mining companies and fire system suppliers, etc. And several iterations of PR4 were carried out before we actually settled on or landed on its current format with the major miners. So it helps sort of understand how we progress from the potential unwanted event into what are the functional design performance requirements. So you heard me talk earlier about the control framework driver tree, and this work led to the development of the like I said, this is the fire event tree, and the areas of influence. And I guess I'd just highlight a couple of things there. Note the mobile equipment design, the mobile equipment maintenance, the fire detection and suppression systems, and also the operating company's emergency and crisis management. And you heard me talk earlier about how we all have a role to play, and it's important to highlight that Performance Requirement 4 doesn't consider the mobile equipment emergency response management zone, because we were really only trying to concentrate on the things that we could control as a EMESRT group. So when we finalised PR4, it was a really important milestone for both EMESRT and the technical working group. This sort of talks to the work that we've done to date. So our control framework has really come together with a whole range of multiple information sources. The EMESRT Design Philosophy 4 mobile equipment fires, the regulator information from multiple jurisdictions, national and international, incident reports, bulletins, position papers, and even some of the newer ISO underground mobile equipment standards, search and technical information, and like I said, incident taxonomies. And we've also had a pretty close look at the relevant standards and guidelines. And I think I just mentioned 19296, which is a new standard, a relatively new standard when we kicked off our project in 2018. So we validated the control framework at several multi-day industry workshops. And we have updated Design Philosophy 4, but we are awaiting some small illustration before we complete it. Our Knowledge Hub has been developed, and it's now been published, and we'll show you a little bit of that, and some of the curated content has been uploaded. But this is I guess you never really get to the end point. So as each incident around the industry occurs, what we do is we compare it to our existing control framework, and if there's additional elements that have not been previously identified. We update it, and that, if you like, continues to evolve as an industry knowledge hub, right, which was what it was intended to do. The knowledge hub is an interactive navigation graphic, and it's linked to the topic areas and subtopic areas identified in our PR4 document, and users can easily navigate to their topic of interest. And we've now published this. So this next slide gives you a little bit more detail, and you can actually see where there's subsections under each of the maintenance, the design of the fire suppression system, the design of the asset, and also the yellow elements at the bottom, which for our exercise were not included, but talk to the emergency and crisis management procedures, both, immediate on the asset, but also from a wider perspective on sites. We're in the process at the moment of preparing for our next discussions with our OEMs, and we've been able to sort of flush out the key things. And there's a vulnerability of existing fluid supply mechanisms. What do we mean by that? Using oil, oil-fed turbo lines, rather than having those things perhaps designed in an alternative way, perhaps through block-fed porting. There's a whole heap of those sorts of examples. There's use of flammable materials in existing energy drive and associated construction systems. So you heard me talk a little bit about the fire event we had. Some of the materials that are used on some of the assets, whilst they're fire resistant, actually become fuel once they reach a certain flash point or a certain temperature. Designs that allow flammable material buildup, and we work across a whole range of different commodities. So if you think about, let's say coal, have a think about all the the horizontal surfaces and little areas where in heat affected zones where coal could potentially build up and then either self-ignite or become ignited by adjacent materials. Integration of the fire suppression system logic. So this is another key finding, and this is really relevant because a lot of our late model machines actually have CAN bus and other control type interfaces, which make the traditional wiring loom and logic interrogation a little bit more tricky because it's software and it's IP, right? So, we don't want situations where someone can isolate a fire system and still have the asset be operated. We want machines that can actually anticipate a fire event, throttle back where the machine's constantly being stalled out or beyond its design requirement. We want to be able to have the correct detection. We want the correct actuation. We want reporting such that it's clear so that our sons and daughters can actually understand whether the machine's healthy or not, or whether they should operate it. We want alarm prioritization. What does that mean? That means that there's a whole heap of stuff going on at any one time in the cab. And if there's a fire event or there's some event that requires prioritization over all other messages, then it needs to be discriminated that way. So that's the sort of stuff, right? Inability of fire suppressants to extinguish certain flammable materials. and emerging energy drive systems. So, we are about to see a whole heap of alternative energy assets entering the industry, and we'd like to take the learnings from our existing asset base into those designs. I guess we published PR4. It was a major milestone, the technical working group and other contributors, but there's still more to be done. So we're in the process of finalising and publishing Design Philosophy 4. The mobile fire control framework pilot trials are underway. We've reviewed and gained approval, like I said, and the knowledge hub's been done. We're in the process of publishing the Mobile Equipment Fire Management Project report. And one of the really good things that have also occurred in 22 is that an old ISO standard 13649 is being revisited. That particular project was put on hold, and it talks to what needs to happen to minimise fire events on mobile equipment. So that's I thank very much the member companies who have helped sort of lift that. And I guess a couple of other key things as well is that a number of the EMESRT advisory group have also received ISO liaison status to help us provide feedback and key end user information on key areas that we're focusing. So I guess in today's presentation, I've talked a little bit around the background and the EMESRT approach and who was involved. I've talked to the control framework and how it allows us to see this issue in a different way, particularly that we've all got a role to play. The importance of current state assessments and developing your baseline, because about 80% of the fire events we do have, we have all played a role in. The status of the work, which has involved many individuals from the organisations on our call today, and what the next steps are. So I guess just in winding up, I'd like to thank all the working group members and other industry participants and their sponsoring companies for making this project a reality, and the AG for giving us the opportunity to talk today.
Mark, sorry to interrupt. It's just worthwhile mentioning also that we will continue with the technical working group monthly meetings. We extended the meeting to an afternoon session that started on the 1st of November. We meet at 8 o'clock on the first Tuesday of each month, and then we repeat the session at 4 o'clock on the same day. That was designed to meet the different time zones. And like I said, we started that process on the 1st of November and will continue to do so moving into the future.
Hi, thank you for the presentation, Mark. Only to consider maybe in other analysis in the future. I miss the electromobility, like root cause analysis in especially in underground, because maybe the industry move forward in this kind of equipment. Thank you.
Okay. Look, thank you. One of the parcels of work that we've been doing with one of our member companies is actually trialing some predictive analysis and testing our baseline and our control framework in their context, and that work is that's progressing pretty well, and we we're pretty comfortable with where that's going.
Okay, thank you.
I just want to say thanks to Mark for the presentation. It was fantastic, and also demonstrated the amount of work involved. And I guess a comment as well, Mark, is the part the regulator plays. We're seeing obviously that they report and some of your pictures there. So I guess it's as Tony said at the beginning, it's that education piece and getting the word out to all of the organizations. So this is, I think it's great to see.
Thank you, Paul. Look, the relationship that we've been able to develop with the regulators has been great. And whilst it wasn't mentioned in our presentation today, the regulators have actually asked us to come and present at their mining engineering forums. So Tony and I have been privileged to attend both the Queensland and New South Wales mining engineering forums, where we've had the opportunity to present this information to, all of the engineers that are in those statutory and accountable roles, both surface and underground, around this work. And, if you think about, the regulators, those guys and girls have been really trying to turn the dial or change things. And, we can see what happens if we don't involve the regulators. They can potentially start, choosing recommendations that might not even be practical from an end user's perspective. And we've seen some of that come out of some of the regions where ongoing issues of not so much in fire have continued to occur.
Mark, it's worthwhile pointing out that in particular the Queensland regulator, they're a part of the EMESRT technical working group, and they contribute. They attend our monthly meetings, and they also contribute to workshops and so on.
Yeah. It's just a really, really great environment. I got to admit, there's no status. Everyone leaves their cap at the door, and it's a really, really positive. We're all focused on trying to get the same result, right?
Yeah.
Yes.
Marcus, Tony, if I could comment about why it's been successful, is that there's a great saying about everyone's entitled to their own opinions, but not they're entitled to their own facts. And what the control framework does is bring together a set of facts. And what that then does is allows people to align in their thinking. And if you think about why the just different groups in the industry have been maybe not aligned in the past, it's because we've probably been more based around opinion without a depth of understanding that the control framework's now provided us. And to me, that's the core of why this is working. I mean, people are committed and they're enthused and all the other things. And we've seen that in other mechanisms in the past. Many years ago, there was an exercise using bow ties in this space, but it didn't deliver the clarity of outcome that the control framework has given us. And to me, that's the platform that's really made the difference.